So I'm teaching a Calculus 1 class right now in the summer, and I was just going through the book because I had to pick some questions to assign for my students for assignments, and I saw this. And this is from the L'Hopital's rule section, and by the way, I use James Stewart Calculus textbook. And I saw the x to the x power, so I thought this was going to be a nice question because we will have to differentiate the top and differentiate the bottom, and we go from there. In fact, we don't have to do that. In fact, don't do that. Here's the deal. If you look at the limit, right, let me make a note right here. As x approaching 0 plus of this part, just x to the x power, this is actually just equal to 1. And the reason is not because you have 0 to a 0's power is equal to 1. 0 to a 0's power is an indeterminate form when you do limits. You don't know what the answer is yet unless you do more work, which I will do it for you guys later. But if you know this right here is equal to 1, or maybe you have seen my previous video or whatnot, you can just put 1, replace with that. So this will give you 1 right here, and then minus this 1 over. If you put 0 plus into ln x, well, ln of 0 plus, I know this is a bad notation, but this right here approaches negative infinity. And the reason is, if you look at the graph for natural log of x, as x approaching 0 from the positive direction, you see the function goes straight down. That's why we end up with negative infinity. So this thing right here is negative infinity, and then plus 0, doesn't really matter, and then minus 1. So what's going to be is what? On the top is just 0, on the bottom it's just negative infinity minus 1, still negative infinity. So the answer is actually just equal to 0, and then you are done. Yeah, just like that. So I'm not going to assign this one because most people will actually just say 0 to a 0's power is equal to 1, and this will happen. Nothing too much. So yeah, I thought it was going to be a nice question. Or maybe the point is that they want us to do this in detail. Okay, if that's the case, let's do that in detail then. So the limit as x approaching 0 plus, you don't want to have a function for the base and the function for the exponent. You would like to have base e. So for this x, we are going to write it as e to the ln x power. If you cancel, you still get the x back. But we still have another x. Raise this to the x power, we multiply the exponents, so I'll put the x right here. So now, if you look at 0 plus into here and here, you get 0 times negative infinity. So this is another indeterminate form. Take care of this. I will just look at the limit as x approaching 0 plus. Actually, no, I'm going to look at this like this. Put this right here. E to the limit of x approaching 0 plus. Now, I will keep the ln x on the top over the x down, which is x to the negative 1 or 1 over x, doesn't matter. And then this right here on the top is negative infinity. The bottom, when you put 0 plus into here, 1 over 0 plus is positive infinity. You will get indeterminate form, infinity over infinity. The negative doesn't matter. Here you can use L'Hopital's rule right here. So d dx dx. So we are going to get e, and then look at the limit as x approaching 0 plus. On the top, we have 1 over x. On the bottom, negative x to the negative 2, which is the same as negative 1 over x squared. And then take care of this by multiplying the top and bottom by x squared. So we can get e to the power of a limit x approaching 0 plus negative x squared over x, so just negative x. Put 0 into here, we get e to the negative 0, which is just 0. E to the 0 is equal to 1. So this is how you will show all the work for that. Yeah. But I was expecting to differentiate the top because I really want to differentiate x to the x power, not this. So in this video, actually it's almost done, but like this, in the second part of the video, I'm just going to change it so that we really have to do L'Hopital's rule right here. Let's take a look. Okay, So since if you plug in 0 plus into all the x's, the top is 0. So that means the bottom should also be a 0. That way I can use L'Hopital's rule for this. Well, this is 0 minus 1. So I need to have this being 1 when x is 0. So we'll have different choices. Maybe cosine x. But since we're talking about exponential, right? Because x to the x power, let's just use another exponential. Let's say e to the x. Plugging 0 plus into all the x's, we get 0 over 0. L'Hopital's rule. D dx d dx. Okay, so this is the kind of question that I might put on my quiz or test to my students. Anyways, limit as x approaching 0 plus. They are not watching. I don't know. I am not sure. I don't think so. But anyways, all right. Differentiate x to the x power, which is a standard question in Calculus 1. And you can do it real quick or watch my other video, but I will do it real quick right here. Why not? X to the x power. Again, x, you write it as e to the ln x power. And then you multiply with this x. And then when you differentiate this part repeats. And then use the chain rule. You multiply by the derivative of inside. Here you need the product rule. Keep the first function times the derivative of the second plus the second function times the derivative of the first. Let me just say the first function is in blue. Now, what's this? It's just that. What's that? It's just this. So this is x to the x power. And then this is just 1 plus ln x. So the derivative of x to the x power is this. X to the x times 1 plus ln x. Derivative of minus 1 is just 0. Then on the bottom, you get the derivative of e to the x, which is e to the x. And the derivative of plus x is just plus 1. And the derivative of this is just 0. Now, you're plugging 0 into all the x's. This is going to be 1 per our computation earlier, which we did it legitimately. So you have 1 times 1 plus ln of 0 plus, and then over e to the 0, well actually, yeah, 0 plus right here doesn't matter, and then plus 1. Now, be super careful. On the top is what? This is ln of 0 plus, which is negative infinity. Plus 1 doesn't matter, it's still negative infinity, over 2. So you have negative infinity over 2, and you end up with negative infinity. Yeah, in my opinion, yeah, slightly more interesting